So we were actually doing quadratics, and in the last session, we talked about the concept of discriminant, right? Now, these were the different cases that we had for discriminant. There are 4 possibilities, 3 base cases, and then 1 case that is actually made up by combining the first 2. Let me quickly go over this, and then today we want to do some practice questions, and hopefully towards the end, we will be pretty confident. By the end of this class, we would be very confident with using this concept in all the different types of questions that come regarding this. There is one thing that we have to do apart from this, and that is we need to learn how to solve quadratic inequalities. So that is also going to come. You can just see if we can do that today as well. So we started from question number 3 the other day. We did one part of it. We did question number 16. We just did one part of this as well. And we talked about discriminant, and then we did question number 11 from the worksheet. All right. Okay, so first of all, before we actually move on, I would want to do some practice questions on this so that we are more confident about these concepts, and then we can move on after that. Okay, so I'm going to focus on some practice first, and then after that, we will see if we have enough time today, we will start the next concept, that is quadratic inequalities. But if not, that's okay. We can do that at the start of our tomorrow's class, and then do some practice on quadratic inequalities as well. All right, so this is what we did in the last session. We talked about these 4 different cases. The first was when b square minus 4ac is greater than 0. When this is the case, you say there are 2 real and distinct roots of the equation that you have. And graphically, what it means is that the line and the curve, they intersect at 2 different points. When the discriminant b square minus 4ac is equal to 0, in that case, you say there are 2 real and equal roots, or in other words, you can also say there's only 1 real root, because essentially if the number is repeated, you can say it's just the same number, okay? Graphically, it would mean that the line is a tangent to the curve. Then there's a third case, b square minus 4ac less than 0. In this case, you have no real roots. And graphically, that means that the line and the curve, they do not intersect. Now, sometimes what would happen would be, you'll just be given that some equation has the real roots. Okay, now since you do not know whether there is only 1 root or 2 roots, that means it could be the first case or the second case. So you combine both of them and you say b square minus 4ac is greater than or equal to 0. This could also be another possibility in this last case. Graphically, what that would mean would be, they would say the line and the curve, they meet each other. Now they meet each other, but we don't know at how many points. It could be 1 point, it could be 2 points. So that's why we say it could be the first case or the second case. So we write it like this: combined greater than or equal to 0. All right, so you should be familiar with these cases because you will need to use them in different types of problems. All right, so this is what we did in the last session. Now today, since we haven't done enough and a lot of practice until now, I would want to focus on doing some practice questions so that we get more familiar with how this is tested in the exam. So we have done question number 3, 16, and 11 earlier. Now let's start with another question from the worksheet that you have. I also hope that you would have attempted questions from the worksheet yourself as well. If you did, And you have any problems, you can also write them down in the chat box. If there were any questions that you could not do, we would also discuss them during today's class, inshallah. I'm going to start with question number 1 from the worksheet, because this is one question that actually tests a number of concepts that we've done until now. So it will be a good practice so that we can, just revise everything that we've done until now through this question. Okay, so this is question number 1 from the worksheet that you have. Let's have a look at this. So it says the equation of a curve is y equals x squared minus 3x plus 4. And in the first part, it says, show that the whole of the curve lies above the x-axis. This is what we want to show, that the whole of the curve lies above the x-axis. Now, how do we think about this? There could be 2 ways of thinking about this. You could say, let's find the turning point of this graph. Okay, find the turning point of this graph. You see, it's a quadratic function. Quadratic functions can have 2 possible shapes. They can either be U-shape or they can be N-shape. Now, if you think about this one, the coefficient of x squared is positive, it's +1. And when the coefficient of x squared is positive, you get this first shape. So it's a U-shaped graph, all right? That's the first thing. This graph is a U-shaped graph like this, okay? Because the coefficient of x squared is positive. Now, what we want to show is that the whole of the graph lies above the x-axis. That means the x-axis should be somewhere here, below this curve, all right? Now, one possibility is that we show that this turning point, which is the minimum point of the graph, is positive. Its y coordinate is positive. That could be one idea, that you find the turning point of this graph. All right. Now, how do we think about this? Let's find the turning point. So remember how we used to find the turning points of quadratic functions? There were 2 methods that we did. One was using a formula, x equals minus b over 2a, right? That was one formula. Let's start with that. So this is the function that we've got, y equals x squared minus 3x plus 4. Okay, this is the function. How do you find the turning point? One possibility is that we use this formula, x equals minus b over 2 times a. Now, what's b in this function? B is minus 3. So in the numerator, we've got minus into minus 3 divided by 2 times a. A is the coefficient of x squared, which is just 1. So the x coordinate of the turning point turns out to be 3 over 2. Now, how do you find the corresponding y coordinate? You put this value back in the function, and that is going to give you the corresponding y coordinate of this function. All right, let's try and find that. We get y equals 3 over 2 whole squared minus 3 into 3 over 2 plus 4. Okay, and now you evaluate this on your calculator and see what you get. 3 over 2 whole squared minus 3 times 3 over 2 plus 4. And just check what I get from this. All right, so this is giving me 7 over 4. So the x coordinate was 1.5, and this is 1.75. So now if you look at the graph, the coordinates of the turning point are 1. If you look at the graph, the coordinates of the turning point are 1.5 and 1.75. Let me just write them here. This point is 1.5 and 1.75. Remember what your x-axis is? At the x-axis, y equals 0. Now, since the value of the y coordinate of the turning point is positive, this value is positive, that means all of this function, the whole of this function lies above the x-axis. So what you can say is, on the y-axis, the minimum value of the curve, is 1.75. And this is a positive number. It's a positive number. That means this minimum point lies above the x-axis. If the minimum point lies above the x-axis, that means the whole graph has to lie above the x-axis. Okay, so since this is positive, you can say the whole curve lies above the x-axis. All right. This is one idea that you can use here. You could say the whole graph lies above the x-axis because the turning point, the minimum point, is above the x-axis. All right. Now, there could be another way of thinking about this as well. And what could that be? You could say, since the whole of the curve lies above the x-axis, that means there is no point of intersection between this x-axis and the curve. It does not have any solutions. It does not have any x-intercepts. What does that mean? B square minus 4ac should be less than 0. So if you can prove that the discriminant is less than 0, that could help you prove that the whole of the curve lies above the x-axis. Let's try that. So you have this function y equals x square minus 3x plus 4. Another possibility here could be that you find the discriminant. Find b square minus 4ac. What does that turn out to be? Minus 3 whole squared minus 4 into 1 into 4. And that gives me minus 7. And this is a negative number. So that means b square minus 4ac is less than 0. Okay, b square minus 4ac turns out to be less than 0. So b square minus 4ac is less than 0. That means there is no x-intercept. The curve does not intersect the x-axis. But this is not enough. This is not enough. Why? Because just proving that discriminant is negative only means that the line and the curve, they do not intersect. Now, there could be two possibilities from this. One possibility could be that your graph looks like this, that the whole graph lies above the x-axis like this. That could be one possibility, and that is the one that we want. But just proving this could also mean that the curve looks like this, because this curve also does not have any point of intersection with the x-axis. All right. So it could be either this case or this case. So this is not enough. You would also have to write. So this is one thing. Discriminant is negative. You would also need to show that it's a U-shaped curve. So it's this curve, not the curve below. So how would you show that? You would either just write that it's a U-shaped curve, or you first say that the coefficient of x square is positive. That is why it's a U-shaped curve. Now, if it's a U-shaped curve and it does not intersect with the x-axis, there's only one possibility that the whole curve lies above the x-axis. Okay, the whole curve has to lie above the x-axis. So these two things together, they mean that the whole curve lies above the x-axis. Because there are no x-intercepts and it's a U-shaped curve, it has to lie above the x-axis. Now, it also might come to your mind that it could look like this. Is that possible? That the whole of the curve lies below the x-axis such that it's a U-shaped curve? What do you think? Is this a possibility? Anyone? Is this possible? The whole curve lies below the x-axis like this. It's a U-shaped curve and it lies below the x-axis. Would that work? This is not going to be possible because remember, this curve is a never-ending curve. It's going to extend on both sides like this. So at some point, it is eventually going to intersect the x-axis if some part of it was below the x-axis. Okay, so at some point, it is definitely going to intersect. All right. So this is not possible. The curve cannot be below the x-axis. If it's a U-shaped curve, it can only be above the x-axis. The whole of the curve can only lie above the x-axis. That's the only possibility that we've got. Okay, so it's going to look like this. So this could be another way to prove this. You could prove that the discriminant is negative, and also at the same time, it's a U-shaped curve. All right. Okay, now let's look at the second part. In the second part, it says, find the set of values of x for which x squared minus 3x plus 4 is a decreasing function. All right. You have to prove, you have to find the set of values of x for which this is a decreasing function of x. Let's think about this. Part 2. Remember, we talked about decreasing functions when we talked about the graphs of quadratic functions initially. So if you have a graph like this, and from left to right, it's going downwards, it means it's a decreasing function. And if from left to right, it's going upward like this, this is an increasing function. What's the difference between the two? In the decreasing part, the gradient is negative. Okay, so it's a downward sloping curve in that part of the curve, in that part. And in the increasing part, the gradient is positive. It's an upward sloping curve in this part, so the gradient is positive. So if you look at a quadratic function, on one side of the turning point, it is always going to be increasing, and on the other side of the turning point, it's going to be decreasing. Okay, it's a U-shaped. If it's a U-shaped curve, on the left side, it's decreasing. On the right side, it's increasing. And it's the other way around for the N-shaped curve. Okay, so we've talked about this before, and we discussed graphs. So if you think about this curve now, it's a U-shaped curve. We know that. It's a U-shaped curve. This is something that we know. And we've also found the turning point in the previous part if we used this first method. If not, we would have to find the turning point in that case. The turning point was 1.5 and 1.75. Let me write that here. The turning point is 1.5 and 1.75. All right. Now, we need to find the values of x for which this function is a decreasing function of x. So basically where the gradient is negative. Decreasing function means the gradient in that part should be negative. Look at the graph. Where is the gradient negative? It's to the left of the turning point. So it's this region on the graph. We need to find the values of x in this region. Now the x coordinate that we've got here for the turning point is 1.5. So decreasing part is going to be towards the left of this point. So towards the left of 1.5. This is the decreasing part on the x-axis. So what do you write then? You say x should be less than 1.5. This is where it's a decreasing function in x. Make sense? Any problem with this? So here you just have to write this down. Okay, so that's 1 mark. Let's look at the next one now, part 3. Okay, so now it says the equation of a line is y plus 2x equals k, where k is a constant. In the case where k equals 6, find the coordinates of the points of intersection of the line and the curve. All right, so we have the equation of a line given. We already have this curve above. Let me write down both of them here. Y equals x squared minus 3x plus 4. This is the equation of the curve, and the line is y plus 2x equals k. You can write this down as well. Y plus 2x equals k. This is the straight line. Now, what we're looking for is the coordinates of the points of intersection of the line and the curve. Now, how do you find points of intersection? We talked about this in our last class as well. In order to find points of intersection of two graphs, we basically solve them simultaneously. All right, because if you have a curve like this and a line like this, in this case, it's a downward sloping line, so maybe something like this. These are the points of intersection that we've got. What is special about these points? At these points, this curve and this line, they have the same x and y coordinates, right? Their x coordinates and their y coordinates are equal at these 2 points. So what we do is we basically equate both of them somehow. We either make y the subject in both of them or x the subject in both of them and then equate them. Or we can do substitution like we used to do in O-levels. So whatever you want, you just have to solve them simultaneously. Okay, that's the idea. Now let's solve them simultaneously. We've got 2 equations. Take it down there. Okay, how do you solve them now? One idea is you make the same variable the subject in both of them. From the quadratic equation, you already have y the subject. So you can say this is y equals x squared minus 3x plus 4. It can stay as it is, in fact. From the other equation, you can make y the subject so that it becomes y equals k minus 2x. And now you could just equate these 2 equations. But remember, we are given the value of k here. And the question in the third part, it says the value of k is 6. So we can input 6 here in place of k. K is 6. This is the equation that we've got. Now we equate both of them because we've got y, the subject in both of them. So it becomes x squared minus 3x plus 4 equals 6 minus 2x. Now take everything to one side. It's a quadratic equation. Take everything to one side. That gives you x squared minus x minus 2 equals 0. Now you can think about whether you can do factorization here or not. I could use 2 and 1. So it becomes x squared minus 2x plus x minus 2 equals 0. If I take x common here, that leaves me with x into x minus 2 plus 1 into x minus 2. And we get 2 factors, x plus 1 into x minus 2 equals 0. And x equals minus 1 or x equals 2. These are the 2 values of x that I'm getting. All right. Now, these are the x coordinates of the points of intersection. What about the y coordinates? We can input these values in any one of those 2 equations. It's going to be easier to put in the linear equation. The calculation is going to be easier. So we input these values there. Y equals 6 minus 2x. Let's input minus 1 once. That gives us 6 minus 2 into minus 1. And then input 2, y equals 6 minus 2 times 2. The first value gives us 6 plus 2, which is 8. And the second one gives us 6 minus 4, which is 2. So the points of intersection that we're getting are minus 1, 8 and 2, 2. So if the graph looked something like this, these would be the coordinates minus 1, 8 here and 2, 2 here. You don't have to draw this. This is just for your own understanding. This is how it's going to look like. These are the points of intersection of those two lines. Make sense? We just solved those two equations simultaneously. Any problem with this? No? All right, let's look at the next part. Now, in the next part, it says, find the value of k for which the line is a tangent to the curve. All right, this is what we're looking for now. Find the value of k for which the line is a tangent to the curve. Remember, k equals 6 was given in the previous part. It's not relevant here anymore. That was in the previous part. So now what you do is, you use this, that the line is a tangent to the curve. What does that remind you of? Line is a tangent to the curve. We did this yesterday. These are the three possibilities that we've got. Where do you see the line as a tangent to the curve? This is the case. The second one here, the line is a tangent to the curve. What's the discriminant here? B square minus 4ac is equal to 0. That is what we're going to be using here. Now, we've got a quadratic function. Let me write that down here, part 4. We've got this quadratic function, y equals x squared minus 3x plus 4. And we've got a line which is y plus 2x equals k. So this becomes y equals k minus 2x. What we're given is that this line is a tangent to the curve. What that means is this line has only one point where this touches the curve. Okay, so what we have to do is we have to put b square minus 4ac equal to 0. That is what we want to do. But before we can do that, we need this form, which is ax squared plus bx plus c equals 0. For that, what we do is we equate both of them. Why? Because there's one point of intersection. So where do points of intersection come from? They come from equating the functions, right? We solve them simultaneously like we usually do. So we first put them equal to each other. That's how we start. We put both of these functions equal to each other like we did in the previous part, but there we had to find the coordinates. Here we can't find the coordinates because we have a k here. So we just equate them. We start by doing that. We start with that process of finding the points of intersection. Let's equate them. That gives us x squared minus 3x plus 4 equals k minus 2x. Right? This is how you find the points of intersection. You equate both of them. Now take everything to one side. X squared minus 3x plus 2x plus 4 minus k equals 0. Now, if the line is a tangent to the curve, this equation should give us only one solution. And that means b squared minus 4ac should be equal to 0. So in this equation, what you're going to do now is you're going to input b squared minus 4ac equal to 0. Let's simplify this first. This gives us x squared minus x plus 4 minus k equals 0. Now let me first write what is A, what is B, and what is C. So compare it with the standard form. In place of A, you've got 1. In place of B, you've got minus 1. And in place of C, you have 4 minus k. So C is all the terms that do not have an x in them, right? So wherever you don't have an x, that's a constant. So in this case, that's 4 minus k. So the value of C is 4 minus k. And now what we do is we say, since the line is a tangent to the curve, b squared minus 4ac, this should be equal to 0. All right, now let's just input values. This gives us minus 1 whole square minus 4 into 1 into 4 minus k. And this equals 0. Now we just need to solve this equation. Let's see what we get from this. 1 minus 4 into 4, which is 16, minus 4 into k, minus 4 into minus k, which is plus 4k. Now we've got minus 15 that goes to the other side and becomes plus 15. And the value of k turns out to be 15 over 4, which is 3.75. This is what we were looking for. All right, so we had the equation of a curve given, equation of a line given, and we were told that they have only one solution. So that means b square minus 4 should be equal to 0. So what we did was we equated both of them, converted them to this form, and then put b square minus 4ac equal to 0. And that gave us the value of k there. Make sense? Any problem with this? Any quick questions on this? All right, let's have a look at another one then. All right, let's try this. This is question number 12 from the worksheet. Let's try this. Okay, so a straight line has equation y equals minus 2x plus k, where k is a constant, and a curve has this equation. Okay, so it did not copy correctly. Just do it again. This is 12. All right, so this is what we've got. A straight line has this equation, y equals minus 2x plus k, where k is a constant, and the curve has this equation. Show that the x coordinates of any points of intersection of the line and the curve are given by this equation. Now, how do you do that? This is the line, this is the curve. How do you find points of intersection? You equate both those functions. So all you have to do is just equate those two functions and then show that that equation can be written in this form. Okay, let's do this quickly. So you got a line and a curve, we just equate both of them. And that gives us minus 2x plus k equal to 2 over x minus 3. Now if we multiply this denominator on the other side, that gives us x minus 3 into minus 2x plus k, that equals 2. Let's multiply these two expressions and we get minus 2x squared plus kx plus 6x and minus 3k. Let's take this 2 to the left side as well. We've got minus 2 equal to 0 here. All right. Now let's simplify this a bit. What we can do is we can make the coefficient of x squared positive first, because you see in the form that you have to show, the coefficient of x squared is positive. It's plus 2. You're getting minus 2. So in order to get plus 2 here, just multiply the whole equation by minus 1 first. And that gives us 2x squared minus kx minus 6x plus 3k plus 2 equals 0. And now that's the form that we want. All we have to do is take x common from these two terms, and of course minus outside as well. That gives us k plus 6 inside. You've got x then, and then you have the constant 2 plus 3k. That's exactly what we've got here. You can leave it like this as well, or just write in the form that is given there, 2 plus 3k. This is what we had to show here in the first part. Okay, we just had to equate both of those functions and convert it to the form that is given. Now in the second part, it says, find the two values of x. In fact, find the two values of k for which the line is a tangent to the curve. Again, the line is a tangent to the curve. That means b square minus 4ac should be equal to 0. Now we already have that form, ax square plus bx plus c. This is already in that form. We can just input b square minus 4ac equal to 0 in this directly. What's the value of a? In place of a, we've got 2 here. In place of b, we've got this whole thing, which is minus into k plus 6. The minus sign is going to come here as well, because that's the coefficient of x, this whole thing. And the value of c is 2 plus 3k, because c is anything that does not have a constant in it. And now what we do is we put b square minus 4ac equal to 0. Let's just input values. B is minus into k plus 6 whole squared minus 4 into a is 2 into c is 2 plus 3k. And this should equal 0. Now let's simplify this equation. We've got a negative sign outside. Negative squared is always positive. So we can just evaluate this thing, k plus 6 whole squared. And that will give us k square plus 12k plus 36. Now evaluate this thing. You can do it step by step if you want, or directly, that's your choice. Minus 4 into 2 into 2, that is going to give me minus 8. Minus 4 into 2 into 3k, that gives me minus 20. No, sorry, this is 4 into 2 into 2, that should be 16, not 8. Sorry about that. This is minus 16. And then 4 times 2, 8. 8 into 3, that should be 24. So we have minus 24k, and that is equal to 0. Now we just solve this equation and find the values of k that we get from this. We have k square minus 12k plus 20 equal to 0. Now we see if we can factorize this. 10 and 2, 10 and 2 work. We could use them. We could say this is k square minus 10k minus 2k plus 20 equals 0. If you take k common, you're left with k into k. You're left with k minus 10 inside. Take minus 2 common here. And that also leaves you with k minus 10. You get 2 factors, k minus 2 into k minus 10. And the values of k that you're getting from this is k equals 2 and k equals 10. These are the two values of k that we were looking for. And the question, it says find the two values of k. So these were the two values that we had to find. All right. So that is what we do here. Now let's quickly have a look at the last part of this. It says find the coordinates of a and b and the equation of the line AB. Okay, but before this, we've got some information given. It says the two tangents given by the two values of k found in part 2 touch the curve at points A and B. All right, so we found some values of k in the second part. It says you get two tangents from that. How? Because if you were to input that value of k, those values of k in this function, you would get minus 2x plus 2 and minus 2x plus 10. You get two functions from that. And they're both tangents to the curve at points A and B respectively. So they're tangents at different points on the curve. What we need to do here is we need to find the values of A and B. Now think about this. We've got the function, the curve. Let me write that down here. The curve is y equals x squared minus 3x plus 4. And we've got a tangent, which is y equals minus 2x plus k. Right? It was y plus 2x, I think. Yeah, minus 2x plus k. So that's what you have. We've got two values of k. One is k equals 2 and the other is k equals 10. So we're getting two different tangents from this actually. One of them is y equals minus 2x plus 2 and the other is y equals minus 2x plus 10. They have asked us to find the equation of the line AB and also the coordinates of A and B. So the points where those tangents touch that curve are called A and B here. We need to find the coordinates of A and B first. All right. Now, how do we start? We've got two sets of simultaneous equations to solve here. Number one, we need to solve y equals x squared minus 3x plus 4 and y equals minus 2x plus 2. This is one set of equations that we have to solve. And the other set of equations that we've got is when the value of k is 10, which is y equals x squared minus 3x plus 4 with y equals minus 2x plus 10. We need to solve both these sets of equations simultaneously. All right. Now let's do this. So let's solve the first set of equations. So we already have y, the subject in both of them. We can just equate the right-hand sides. And that's going to give us x squared minus 3x plus 4 equal to minus 2x plus 2. Take everything to one side, and that gives you x squared minus x minus 2 equals 0 here. Now we try to solve this equation. Can we factorize this? We can. It becomes x squared minus 2x plus x minus 2 equals 0. We get two factors from that. X minus 2. No, sorry. We have x squared minus 3x plus 4. There's something wrong. It seems it should have been plus 2 here. Yeah, so it's plus 2. It's not minus 2, it's plus 2. 4 minus 2, when this 2 goes to the other side, it becomes plus 2. X squared minus x plus 2. Now, the factors for this are going to be minus 1 and minus 1. Is that going to work? Let me just check the working again. We've got x squared minus 3x plus 4. That is correct. Okay, I'm sorry. So I just have the previous equation in my mind. The one that we used in the last question. Sorry about that. It's not the same curve. It's a different curve. The curve that we got is y equals 2 over x minus 3. So I was using the equation from the last question. That's not the one that we've got here. Let me just change this. Y equals 2 over x minus 3. That's actually the equation that we've got. That's the curve that we have, not this one. So this is y equals 2 over x minus 3 and y equals 2 over x minus 3. So I actually figured that out because since these lines are tangents to the curves, we should only be getting one solution for each of them. We should not be getting multiple solutions. So with the previous equation, I was getting two solutions. So that's how I sort of figured out there's something wrong. But now this is the curve that we actually have, okay? So the curve given in the question is y equals 2 over x minus 3. And this is the tangent, y equals 2x plus k. Now in this, we once input k equals 2 and once input k equals 10. So that is what I've done here. Now let's solve these two sets of equations simultaneously. If we solve the first one, that gives us 2 over x minus 3 equal to minus 2x plus 2. Multiply x minus 3 on the other side. That gives 2 equals x minus 3 into minus 2x plus 2. We need to simplify this. x into minus 2x, that's minus 2x squared. X into 2, that is 2x plus 6x and minus 6. On the other side, we've got 2. Let's take everything to the left side, let's say. That gives us 2x squared minus 8x. This 6 goes to the left as well, and that becomes plus 8. And this equals 0. Now we can simplify this, divide the whole equation by 2. That gives us x squared minus 4x plus 4 equal to 0. If we were to factorize this, you're going to get x squared minus 2x minus 2x plus 4 equals 0. You get two factors from this, x minus 2 and x minus 2. All right, so the value of x that we get from this is x equals 2. Put this back in the equation that we had. Y equals minus 2 into 2 plus 2. And that gives us y equal to minus 2. So the coordinates of one of those points that we were looking for, they are 2 and minus 2. That's 1 point. Now, we are not specified which one of them is A, which one of them is B. We can call any of them A and any of them B. Let's call this A. Okay, let's do the other one now. Let's solve this simultaneously. This gives us 2 over x minus 3 equal to minus 2x plus 10. Again, multiply this denominator on the other side. That gives 2 equals minus 2x plus 10 into x minus 3. Do this multiplication, minus 2x into x minus 2x into x. That gives us minus 2x squared. Minus 2x times minus 3, that's plus 6x, then plus 10x, and minus 30 equals 2. Take everything to the left side. 2x squared minus 16x and plus 32 equals 0. Again, divide by 2 to simplify this. That gives us x squared minus 8x plus 16 equals 0. Factorize this. It becomes x squared minus 4x plus 16. So we've got the coordinates of the point A and the point B. Once we've got these coordinates, we need to find the equation of the line AB. So we've got 2 points. We need to find the equation of the line passing through those 2 points. How do you do that? You've done this in O levels. Do this quickly. So you could either use y minus y1 equals m into x minus x1, or y equals mx plus c, whichever of them you prefer. If we use this, y minus y1 equals m into x minus x1, you need the gradient first, okay? Let's find the gradient. Gradient of AB. Gradient of the line AB. That's y2 minus y1, 2 minus minus 2, that's 2 plus 2 divided by 4 minus 2. And the gradient turns out to be 2 from this. So now you've got the gradient. You can use any of the 2 points along with that. For instance, you could use 4, 2, and just input values in this expression. And that gives you y minus 2 equals, so 2 is coming from here. This is y2, this is y1, and this is x1. All right, for this formula, I'm just inputting values. Y minus 2 equals 2 into x minus 4. And now we just simplify this. This gives us 2x minus 8 plus 2, and y equals 2x minus 6. This is the equation of AB that we were looking for. Okay, so we have the coordinates of A and B, and also the equation of the line that we were looking for. All right, that's it for today. Tomorrow, inshallah, we will be discussing how to solve quadratic inequalities. Okay, that's for tomorrow. We'll start with that and we'll do some more practice questions, inshallah. Okay, I'll see you again tomorrow. Allah Hafiz.